Hello and welcome. We saw that we can have different bases for our exponential functions. 2, 3, we can have them higher, lower, and also bases that are between 0 and 1, like the fractions, 1/2, 1/3, and so on. The most common base for an exponential when you're doing application problems that have to do with nature and even financial things, it's called the natural base E. So E is a number in your calculator. E is approximately 2.718 and so on. It's one of those numbers like pi, right? Pi is 3.14159, but it's a universal constant. So this is called the natural base. Okay, the natural exponential function is e to the x, so you have the base of e. All right, so we're going to kind of shift gears a little bit. We're going to solve exponential equations. So we'll encounter all different types of bases, including the e base. So in our first round of solving exponential equations, we're going to look at equations where the bases, we can match the bases. We can make the same base to both sides. So our goal is to have a base to some exponent, exponent 1, equals the same base to a different exponent. Okay? Because the exponential is a one-to-one function, the only way this could equal to each other is if the exponents equal to each other. So we can cross the bases. Once we're making the same, we can cross the bases and we get an equation between the exponents, right? And then we solve that, okay? In some problems, we can make it to match the bases. In a lot of problems, we can't, and we're going to talk about logarithmic functions that will help us solve those problems. Right? So in this example, we are able to match the bases. We have base of 3 to 2x minus 5. And 27, you go, 27 is 3 to the what power? And we know that 27 is 3 to the 3. Okay, so you try to write both sides so they have the same base. Once they do, they cross out, and we make an equation out of the exponent. 2x minus 5 is 3, 2x equals 8, so x equals 4. Right? So here's our solution.